The last method that we're going to look at actually comes from what is now a way of multiplying taught in elementary schools. So let me kind of give you some background here. In elementary schools nowadays, if they want to teach you what 7 times 3 is, they learn that it means that I have 7 things, so I'd have to have 7 things in a row, and I have 3 groups of that, and if they organize it in what's called an array, or in other words, a set of rows and columns, they can see this grid where they have 3 by 7, and they could actually count up or count by sevens, 7, 14, 21, and they could see that 3 times 7 equals 21. And this leads into the idea of area, and so you could talk about it in terms of an area model, where we've got the length times the width equals the area. As they get more advanced, they start using the idea of base 10 blocks. So if I wanted to take, say, 12 times 3, I would use a 10 block and 2 ones to model 12, and then I would do that 3 times. But then you could see that this grouping really looks like a group that is 10 plus 2 more, and I have 3 rows of that. So we end up with these 2 sections. One section is 3 times 10, and one section is 3 times 2. Or in other words, they're thinking of the 12 as a 10 plus 2, and they're multiplying it by 3. So they have 30 in the first box and 6 in the next box, and they can add those 2 boxes of numbers together to get the total of 36, which is what they get from 12 times 3. This becomes more advanced yet if they want to take something like 243 times 37. They could actually create something that says, here's my 200, plus, then I have 40 more, plus, I have 3 more, and I want to multiply it or find the number of groups of that I need. So across is 243, but down is going to be 37. So I'd have 30 and then 7 more. And so in each one of these boxes, we would simply have to be multiplying single-digit numbers with just a bunch of zeros on them. So for example, 30 times 200 is just 3 times 2, and then there's a set of 3 zeros all together that need to be multiplied. So 30 is just 3 times 10, 200 is 2 times 100, so I have 3 times 2 times 100 times 10, or in other words, 6,000. And so it goes. I can continue going through here and quickly fill in each of these values. 1,428 tens, or 280, and then 21. But to find the total answer to this problem, I have to add up all the pieces that I just got. So I'm going to take the 6,000, the 1,200, the 1,400 from the bottom left there, the 280 from the middle bottom, the 90, and the 21 from the side, and if I add those all up, the total that you get from there should be the same answer that you'd get if you just pulled out a calculator and multiplied. So that's the background behind what we're about to do here with this problem, since we talked in the very first video that this problem really could be thought of, and that was a minus 5x, this problem really could be thought of like a 3-digit number times a 2-digit number. So I could think of it as saying I need my length to have 3 sections, 2x squared, then a section that is a minus 5x, and then a section that is the plus 3. So this length is 2x squared plus a minus 5x plus a 3. Those are the terms that make up that total length, thinking length times width. And then my box would have to have a width that is broken into 2 pieces because there's 2 terms, a 3x and a positive 4. And just like in our elementary school model off on the right, I'm going to go through and I'm going to find each of these areas taking length times width. So in my first box here, I'm taking the 3x times the 2x squared, and that's going to get me a 6x times x times x, or 6x to the third. In my next box, I'm taking the 3x times the minus 5x, or a minus 15x times x, so minus 15x squared. Make sure that that looks like a 15. Okay, in my next one, I have 3x times 3, so that's 9x. And so that's completed my first row. Now I go on to the second row. Notice the first row is just all of this got multiplied by 3x. Now all of the first polynomial will get multiplied by the 4. And so the 4 times the 2x squared is 8x squared. The 4 times the minus 5x is minus 20x. and the 4 times the 3 is 12. Just like in my problem down there, making the box does not actually result in the answer by itself. I now had to add the parts. In our problem in elementary school, the parts were all like terms. They were all numbers. But in our case, not all of them are like terms. So when I add the parts, some pieces can be combined together. For example, x squareds with x squareds and x's with x's. And other parts are just written as that plus the next thing. So I have a 6x to the third. And then I can add with that the total of these x squareds, which is a minus. So I should probably use a subtract instead. So I'm going to use a minus... let's see, that would be 7x squared. And then the total of my x's is a minus 11x. And then I have a plus 12. And so again, we see the exact same answer we had before, but we did it using an area model. And so this is considered the area model, or some people just refer to it as the boxes, way of multiplying. And so that's yet a third method that you could use. And you need to decide which of the three methods works the best for you, what makes the most sense.